Okay, cool. Hello, everyone. Good morning, good afternoon, and good evening from wherever you're joining us. I'm very happy to have all of you here today. My name is Dalia, and I work as a community manager here at Kong. Today, we have Patrick. I will let him introduce himself. Very, very interesting topic today, managing the lifecycle of Kubernetes gateways with Kong Gateway API. So very interesting new stuff we will be sharing with you. This webinar is recorded, and you will be able to see the recording on our YouTube channel afterwards. I will put the link in the chat here so you can go and access it afterwards. Please save for all of the questions until the end, and you can put them in the Q&A function on the bottom so we can keep track of all of the questions. So please insert them there, and he will answer them as soon as he's done presenting. So yeah, please take it away from here.
Hi, thanks, Dalia. So hi, everyone. Today, I'm delighted to talk to you about the managing lifecycle of Kubernetes gateways with Gateway API. We have a packed agenda, so let's jump right straight to it. So briefly about me, I'm Patrick. I'm a senior software engineer at Kong. I'm the maintainer of Kong's Ingress controller as well as Kong Gateway Operator, which I'm going to hear about a little bit today. Today, agenda is as follows. We're going to go through a brief introduction to the Gateway API. Then we're going to review traditional and manual Kubernetes operations with Helm and Customize. Then we're going to touch briefly in general on the subject of operators. What are they and how they can help us? We're going to go through the introduction of Kong Gateway Operator. Then there's going to be some time for a short demo and a Q&A session. So who is this talk for? This is mainly for three types of personas that we like to differentiate. Firstly, is for cluster operators interested in automating operations for network gateways on their clusters. Secondly, it's for developers interested in Kubernetes operator development. And thirdly, for engineers with any level of interest with Kubernetes Gateway API. So let's start with a brief overview of what exactly is Gateway API. Gateway API is a part of Kubernetes SIG network with main focus to be the next generation of Kubernetes routing and load balancing APIs. It's designed to be expressive and extensible with focus on role-oriented resource model, which I'm going to talk about in a bit. Currently, it's heavily focused on HTTP and HTTPS, but already contains a lot of different concepts around TLS, TCP, UDP, gRPC, and other routes. Goals largely come in Gateway API from things learned from Ingress. Some of you might know, and perhaps are still use those vendor-specific resource annotations. The ultimate goal is portability. Migration to different Gateway API implementation should be as easy as changing a class attached to in-cluster resources. The aforementioned role model revolves around three types of personas. Infrastructure provider, that will be typically your cloud vendor. Cluster operator, most often your company's SRE or DevOps team. And an application developer, typically focused on deploying his services to the cluster. Gateway API is centered around the concept and the custom resource definition of a gateway. It describes how traffic can be translated to services within the cluster. It also represents an instance of a load balancer or a proxy. On the slide, you can see an example of a gateway resource. It uses the Kong Gateway class that will be typically provided by your infrastructure provider or defined by yourself if you ever wanted to do so. It listens on port 443 using HTTPS and has its hostname and TLS certificates set. It also exposes its status, which is set by the controller handling the aforementioned gateway class. As you can see here, it was set to an actual address of the gateway under which it can be reached. Second important piece of the gateway API that you might encounter is an HTTP route. It enables HTTP traffic from outside the cluster to services within your cluster. It's analogous to the Ingress API. In the slide, you can see the route attaching to the foo gateway that we defined in the previous slide by using the route's paragraphs field. Similarly to gateway resource, HTTP route also exposes status fields, like for instance, conditions, explaining if it was successfully programmed on a gateway. HTTP routes currently have many more features, and the list is constantly expanding, from commonly known HTTP header or method matching to Kubernetes namespace cross-referencing and many more. We're going to see some of those features in action in the demo later on. Previously mentioned gateway class provides parameters for managing the configuration of your gateways. Gateways provide the specification and status to manage the configuration of your gateways. Unlike the historical Ingress resource, these APIs provide a clear surface for managing the lifecycle of gateways. I highly recommend you visit Gateway API's website for more, since there's tons of valuable information in there. There's going to be links scattered and QR codes scattered across the presentation, which is also going to be distributed across with the together with the recording. Now, with that, we're going to go briefly review the traditional gateway management tools that developers use in their Kubernetes clusters. It's not a surprise to anyone that Helm and Customize are still the incumbent tools used for manifests templating and deployments management, even taking into account all the pain points and that users reported over the years. YAM templates are a far cry from an intuitive tool which you can always rely on. Both of those tools are most often used in production environments in GitOps pipelines using Argo CD, Flags, or similar tool like this. But this often requires a lot of effort and for SRE and DevOps teams to set up and maintain. From those pains with Helm, YAM templates, and several others, the operator pattern has been born. It's a paradigm shift in deployment and configuration management. It's based on software operator deployed in cluster, implementing a reconciliation loop, constantly watching for drift in configuration between a desired state and an actual state. It also allows users to use higher order abstractions to achieve infrastructural goals. Think how the deployment controller manages deployments and what abstractions you could use in your workflows or in your infrastructure. Let software manage, configure, and self-heal those for you. This, combined with Kubernetes custom resource definition system and expressive status reporting, can be a powerful tool in every engineer's tool belt. To make the operator picture complete, it's worth mentioning that operators are not all made equal. Operator SDK, one of the frameworks that help you build an operator, neatly defines operator capability levels, which you can think of as levels of automation that they provide. Comparing that to Helm, as you can see on the slide, operators allow you to go beyond the basic configuration management and upgrade use case. With operators, you can go through full lifecycle management, deep insights, where you can integrate, for instance, the observability signals to your operator, and even go to full autopilot with platform awareness, auto-scaling, and much more. But you might ask, why would I even need an operator? I already have a working deployment workflow and a CD pipeline. What's the point? You could use, there are several points. You could use higher order abstractions. Do not deploy service deployment, secrets, config maps, and much more ingresses, and so on, where you can simply use one gateway and let the operator handle that for you. Using those abstractions will also allow you to get the benefit of resource-centric status reporting. You're trying to figure out why your microservice is not reachable when pods are working fine and they're not crashing. Check your route status that lead to those pods. Probably it will tell you why it couldn't attach. You can also let operator to perform the self-healing of your deployments. Operators understand Kubernetes native resources, and they are watching them from within the cluster, which allows to self-heal your setups in milliseconds. And your GitOps pipeline cannot do that. You can also combine the power of multiple operators. Use the GitOps operator for your source control configuration and management, and the gateway operator for higher level abstractions for networking. Operators can also provide integrations automation. For instance, an operator can find if Cert Manager is also installed with a default CA and automatically use that for signing certs. Now, with that introduction to operators in general, I would like to give you a quick introduction to Kong's very own gateway operator, which will allow you to deploy and manage gateways in your clusters. So Kong's gateway operator, or KGO as we often refer to it, was written with simplicity and ease of use in mind. With a handful of simple commands, it will allow you to deploy and configure gateways in your cluster with very little oversight from you. It supports gateway APIs, resources like gateway and HTTP class, as well as Kong's own resources like data plane and control plane, which serve both as building blocks for gateways and also as a standalone APIs, which you can use if you want more control. Data planes can be especially useful for those that integrate with an already existing control plane, like Kong's Connect. While control plane resources deploy Kong's ingress controllers, which are responsible for translated resources like HTTP routes into Kong's configuration. KGO can also autoscale your gateways using managed Kubernetes autoscalers and much more. Now with that, it's time for a short demo on how you can actually use Kong's gateway operator to deploy gateways in your cluster. What you can see on my screen is a local cluster that I have with several panes of glass to my cluster visible. On the top two windows, you can see the services and default namespace, and also gateways in the gateway API sense on the right-hand side. This is going to help us to see what's happening. I'm going to be deploying and also listing resources in the bottom pane, but it's helpful to have those on the top to see what's happening. I have Kong gateway operator installed in my cluster in the Kong system namespace, and it's already up and running and waiting for my gateway API resources and its own custom resources to be deployed. Let's start with a simple example. I will apply a very simple gateway example to the cluster. It deploys gateway class and a gateway. There's no configuration apart from the listener that's specified on the gateway, with its port protocol, and a binding between the gateway class and the gateway. As you can see on the top window, in the top right window, the gateway has received an address and has been programmed, which means that the underlying building blocks, which I mentioned before, control plane and data plane, have been deployed, and there are several pods for those that are going to be handling the traffic. So if I want to actually query that, I can use that address and I can actually reach the gateway. I have not configured any workloads behind those behind the Kong gateway, so I'm seeing that there is no route matched with the values, with the parameters that I hit. But we can see that it's responding to my request, and I can see that the server that is actually handling that, it's Kong in version 3.6.1. This is good. So if I actually go ahead and remove that, I will not be able to reach anything under that very address. Okay, let's go a little bit more advanced. I will deploy a more complicated and more comprehensive example with two services and two independent deployments. Both are going to be served by the same image. A gateway configuration, which is optional, but I decided to use it. It's KGO's very own type of resource that you can use to configure the control plane and data plane options. Here, I decided to use a specific version for both data plane and control plane, and I've decided to customize that I want two replicas for my data plane. I also decided to customize the readiness probes for those. And in the bottom, I referenced that configuration in my gateway class, and then I deployed the gateway, just as I've done in the previous example. Now, what's new is the HTTP route, which I've decided to include in here as well, which is kind of listen on the path /echo, and it's going to load balance it between the two services, echo 2, echo 1, with ratio 3 to 1. Now, I can also query the status of the gateway with kubectl command. I can use kubectl get gateway and then print its status. Now with that, I'll be able to see that there are several status conditions and other fields that are filled in by our controller. Here's the address, actually one address, but there may be more under which the gateway is reachable. There is several status conditions that are saying that everything was programmed, is ready, the data plane, control planes are ready, and the gateway service through which I can actually reach into the cluster is also ready. Now with that, I can also, in a similar fashion, check the HTTP reroute status. With that, I can check that the HTTP has a parent, which is the gateway that I've deployed. It's been reconciled by our operator, and also all of its status conditions are indicating that it's been properly configured. Good. That if that is all set, then I should be ready to actually reach out to this particular address and then see my deployments reply. I can actually check that the load balancing feature is working and hit that endpoint several times. I should be able to see Echo and Echo 2 pods from Echo and Echo 2 deployments responding to my requests. Okay, good. So we've covered that. There's one more scenario I wanted to show you. let's remove this one. I've mentioned in my presentation that there's also the building blocks, the data plane and the control planes, which you can also use as standalone APIs. Our data plane has a specific field that you can utilize, currently only when you use it as a standalone, which is a rollout strategy, in which you can specify that you want to use a blue-green rollout strategy. So for instance, I've just deployed this manifest. I can check that my data plane is actually up and running. It's ready. And that it has an address assigned through which I can reach to it. Okay, let me try reach it. We still have the same response as in the first scenario. We can see a 404, no matched with those values because we haven't configured it, but it's responding to our requests. So it's good. We can also see that it's running version Kong version 3.6.1. Good. Now with the blue-green rollout strategy, what I can do is I will update the upper right-hand side window to show you the deployments. You can see that there are two of those. One is standing by, and the other one is serving live traffic. Now, if I would like to, let's say, patch the deployment to a different image, that can be a different patch, but I decided to actually check a different version of Kong because I want to test a different version of my gateway, if it's still going to fulfill all my needs. If I patch this, it's not going to patch my live server or my live gateway. This one is still uninterrupted serving the live traffic. But what I have gained is I have gained a separate preview deployment of that very gateway. And how to actually check this out? I can reach out to my data plane status field, and a field inside it will roll out. Now in that specific field, I can find various information. And one of those is going to be the address of my soon to roll out preview version of Gateway, as well as a condition for that rollout. So we can see that we have an address assigned, and this one is awaiting promotion. That means that I can try to reach it through this address, but I can also promote it when I see fit. So let's check. I see still checking the production gateway, that it's still responding to the same address, but I can also reach the preview data plane with a new address. And this one is also responding, which is good. It's also responding with a 404, but I haven't configured any workloads behind it. It's properly configured to use Kong 3.5. Now, let's say I want to promote that. I want to use it in my production live setting. I annotate the data plane with an annotation that the operator should promote it when it's ready, meaning that when all the conditions on the data planes and services and the data plane are set to true, then it can promote it when it sees fit. I'm setting this, and then with a blink of an eye, I'm getting my live version of my gateway upgraded to version 3.5, and the one that I've decided to discard by promotion is not responding anymore. And the reason for that is because I've chosen a strategy break before promotion. This has caused the pause where I was able to actually analyze whether I see the patch as worthy to be promoted to the live version. This summarizes the demo. Let's jump quickly back into the presentation. This was just a quick teaser or the Kong gateway operator. If you'd like to learn more about it, sign up for our next webinar about KGO that takes place on April 4th. Mattia and Gregors are going to talk about it in at full length, and they're going to cover more than I've covered today. You can also get involved in the community. We highly encourage you. There's a couple of links in here. You can join our Slack and ask questions there. We encourage you to read our docs. And also you can reach us at the community group present Kubernetes Slack, on Kong channel and SIG Network Gateway API channel. I encourage you to check out the Gateway API on GitHub as well. There's lots of interesting materials there. And with that, I'm going to leave the floor for questions from all of you.
Thank you very much, Patrick. So let's see if we have any questions from the audience. We'll give it a couple more minutes to see if anyone wants to ask some questions.
We do have a question in chat.
Perfect.
Is Gateway Operator in beta? It actually has G8. Shane, you can correct me if I'm wrong, but I believe we have G8'd last Kong Summit.
Yeah,
if I'm correct.
GA with support for the data plane API 1.2, which is our imminent release, like literally like any second now, is GA with Gateway API support. Gateway API support was beta before this release.
So there, yes. So to complete the answer about beta, there are a couple of features that are still in beta. Most of those are about the new features that we're including in the operator itself. You can check our docs at docs.konghq.com/gateway operator. And there's many. There's a lot of information there, and those features that are still in beta that are marked as such. Shane, you want to pick the next question up?
Yeah,
we have
Laura
also in the
Carmona.
Q&A.
Yeah, Laura asked, is there any material or link you can share with the commands gateway operator? Everything that he linked in there, including the Helm chart, is usable. We are right on the edge of releasing the entire repository open source. We're just in the middle of that, like today. So within a day or so, before KubeCon, which is next week, you will see the whole repo show up and everything will be available there. Otherwise, the things that you can see right now are actually what he's showing in the screen right now. The docs page will kind of get you started, and then the chart can get you started. And then the repo should show up shortly after.
There's a question how to migrate from Istio to Kern Gateway and what are the few advantages. So I'll respond my point of view. The Istio is sort of a different type of a product, I would say, because it has different aspects to it also. But it's more of a mesh solution, which Kong also has one that you can more compare it with. So you wouldn't be comparing apples to apples, I believe. But I'll let Shane comment on that.
Yeah, I think they might be referring to the fact that Istio has like gateways and that you can create them like a gateway in a similar way to what the KGO does. So we currently have support for and regular tests for using Kong Gateway at the edge of an Istio mesh network. So if you want to be able to like use Kong Gateway at the edge of an Istio mesh network, I believe we have documentation on that. I know that we have regular tests that test a matrix of Kubernetes and Istio versions. So that can be done, and you can use Kong and like all of our plugins and stuff like that at the edge of your mesh network. Alternatively, if you mean you want to replace kind of all of Istio, then we would be talking about using like potentially our Kuma or Kong mesh, which has its own gateway implementation, which can be interchanged. So you can use the gateway implementation that comes with Kong is kind of vanilla. It's really basic and just uses Envoy. But if you want something that's like super feature rich and you want to be able to use Kong gateway at the edge of the mesh so that you can use plugins and so forth, that's also possible. You can switch them out. Hope that answered the question. Feel free to ask it a different way if it didn't quite answer your question.
There's one more question in the chat. I see. If we use Gateway API instead of Ingress, will it create Kong Gateway instead of Cloud ALB for L7? So this is basically if our implementation, let me refer to it this way, our implementation of Gateway API operator is that whenever you create a gateway with an operator installed in the cluster, it will create Kong gateways and Ingress controllers, which will be responsible for translating Gateway API resources to configure the data planes. The ALB or a different Ingress, sorry, not Ingress, but the load balancer at the cloud provider level is basically going to be it's basically going to depend on most likely on the annotations on the service that this will be using. We have customization points where you can actually customize those annotations. So this will basically be in an AWS sense, specific annotations for AWS, whether you want ALB or a different load balancer. I hope that answers this question.
I can add on that just a little bit too. So the default, like just right now today, if you create a gateway, is that you will get a service type load balancer under the hood, but it's an implementation detail. And it doesn't always have to be that way. And in the KGO and also in upstream Kubernetes, we are active in looking at things like there's a GEP, which is an enhancement proposal for Gateway API about being able to have gateways on different networks. So being able to say this is part of like this gateway is open to the internet versus this gateway is internal only versus this gateway is on my VPC network, etc. These are things that upstream is currently working on and we will adopt as they move forward, but we're also helping to work on those. So in time, you'll probably be able to see a lot more configurability in terms of like what the actual interface on which things are listening. Today, you can still play around with that, but it's the default case is just to have a service type load balancer and use your default load balancer implementation.
Any last minute questions? Yeah, please. Let's see if we have any more questions coming up.
Yeah, and there's a link to what I was talking about, the enhancement proposal. It's still it's provisional, which means we're still just trying to figure out if it's feasible. There are some problems inherent to Kubernetes' own networking that kind of make it hard to do today, which are things that we're working on and actually are going to be a big source of topic of conversation at KubeCon Paris. So yeah, so that should kind of give you an idea of what we're thinking about in terms of like, right now, we're looking at different routability kind of aspects and configurations for gateways. It's all kind of in there. And please do, if you're interested in this stuff, come join us in the community. That same website, if you go to contributing, will get you to like the regular meetings and stuff like that.
Thank you, Shane, for sharing the resources. Any last questions for Patrick and Shane? And if you come up with any questions later on, you can always find us on the Kong community Slack. Let me type the link here so you can join if you're not a part. So if you ever have any questions, please put the questions there and someone will answer. But yeah, I think That's all. Patrick, thank you so much for the great presentation. Thank you, Shane, for sticking around and helping. You guys were great. And yeah, the recording will be available later today at that link on our YouTube channel. You can find it in the chat. So yeah, we hope to see you at our next webinar on April 4th.
Yep.
Thank
Thank you all very
everybody for
much.
coming. Thanks,
Thank you
Patrick. Thanks,
all.
Dahlia.
Yeah.
Thank you.
Bye.
Thanks, Dahlia.
Bye-bye.
Thanks, Karin. Bye.